to check the code if there are some parts not have been reached. Okay, here we have a decision coverage. Decision coverage, it's a white box test design techniques that are designed to execute all the decisions or the outputs. Okay, if you have one node that have two decisions. Decision is a program point which control flow has two or more alternative routes. Like if we have a switch case, then we have more than two. Okay, a decision output, it is the result. But decision output is a result of that decision. Decision coverage means how many of decisions that have been covered by the execution of testing. Like if you have in the previous control flow graph, we have four decisions, so or four branches. So maybe we cover only two branches, so another two branches will not be covered, so 50%. How to show that with one example here? Decision coverage. This is one decision, this is another decision, or this one without any decision here, so we can go to this decision. So it means this one is decisions based on here, whether to go here or to jump. What is your decision? Whether to meet this condition you run 4, 5, 6, or the decision to jump to run 7 directly. So here are decisions. So during the creating the test cases, as in the previous example, same here, how many test cases required to cover all the decisions? So I want to cover this decision by the first test case, if you remember the previous one, and another decision. I want to cover this decision, and maybe I jump here. So here I can also need only two test cases to cover all the four decisions. One test case to cover this decision and cover also this decision. Another test case, jump, cover this decision, come calculate here, and also jump, cover this decision. So need only two test cases. Same how I did in the statement coverage. I list all the branches that have been covered. And also I have to write how many decisions have been covered based on that. If I remember in the first test case, we cover one. So let me, if you have any questions, you just stop me. So, okay, let me go back to show you the example. All right. Remember that we create here test cases. The previous inputs we have N and M. And here we will write our here branch coverage or decision coverage. Both have same. So I have here M and N. Here my test cases. Input test case number 1. If you remember here, what is in the test case number 1? I write 2, 4, right? So 2 and 4. 2 N is greater, so this decision. If you remember, I labeled here branch 1, branch 2, branch 4. Sorry, okay, branch 3, 3, 4, 4, 3. So the first test case, which branch will be covered? It will go here, and then we'll cover this 4 and 5. 4 and 5, this one. So it will cover branch 2, right? And we'll go here, then it will not go here, right? It will jump. So it will cover branch 3. So branch coverage by one test case, by running one test case, how many branches have been covered, have been executed? 2. Total number of branches or decision coverage? 4. So here I have 50% coverage by one test case. Test case number 2, maybe I select, as you remember, I said only 5 and 15. So again, no, 5, 15, this one will jump here. Again, it will be greater. So let's select another value. You can see here how I select my data. I change because I want to cover. Otherwise, if I use the same test case here, it will cover this part, but again it will cover this part, but not cover this one. But I'm trying here to reduce the number of test cases that cover all the branches. So I don't want here n greater, so maybe they are equal, or maybe they are here not equal 0. So I need, let's say, 6, which is m divided by n result equal. I don't know what is the number should be put here, and then equal n replaced here, then check m divided by n. Greater. What are the results that can be, what are the test cases that can be put here, the values. Okay, then we put here how we can change here. Any help? Use 5, so if not equal 0, yeah, then, but okay, thank you. Then not equal 0, but here again not equal 0 will go again, will go again, will go again. We want some value that will not go again here. Otherwise we can change these values here, and we change the values here. So two test cases. But if you cannot use two test cases, you can use even 3 test cases. So if we use like the previous one, so if we use the previous one, let's say 5, 15. 5, 15 will go here again, but here will go again here. So it will go here, will not equal 5 divided by 15. It will go 1, so which is not 0, so we'll go here. So we'll cover here branch 2 as well as branch 4, but branch 1 not yet. Then we can select another value, test case number 3, which is we can select here 5. Maybe even we can, no need to go equal 0, we can put here 4 and 2. We'll cover branch 1 and branch 3. Let me check your chatting. Someone sent chatting. Okay. You can see here 3 test cases. 3 test cases to cover 100%. So all the branches will be covered by 3 test cases. By 3 test cases. Require 3 test cases. All right. Then after that we have you can see here based on these decisions and coverage branch decision coverage, branch coverage results, we can use them in the exit criteria. Based on here the coverage, how many decisions have been covered, then we can make our decisions to stop testing or continue. As we said here, branch coverage is similar as decision coverage, but sometimes in branch, in decision we don't have anything to be like here. There is nothing. It is branch, but there is no decision here. This is the difference only. Okay. A decision, it means you have some execution and output from this node. Branch, you have this branch, even you don't have anything here. So after that, we will have discuss about what is decision coverage. Decision coverage is a stronger criteria that also will cover statement. You can remember here, when we use 3 test cases, of course, it will cover all the statements. If you want to cover 100% branches, it will cover statement coverage because you already cover all the branches, right? If you cover this branch and run here, this branch and run it, so you by default 100% decision coverage or branch coverage, it will be cover statement coverage, but not necessarily 100% statement coverage will show 100% decision coverage, because if you have, like, let's say here, if you cover only this decision by this one here and come here, so this one is not covered, so statement coverage maybe can use one test case to cover all, and branch coverage you cannot, you don't cover this one. Okay, then we will have something called path coverage. Path coverage, it's the number of paths. What is path? It is the path from the beginning of the starting the function to the end. So this is my first path, my second path here, my third path if I have a loop, and then this one is called infinity, which is boundary here. You have a lot of paths. So by path coverage, it's impossible to be run in the practical, so to cover 100%. But if you cover, let's say 50%, it's guaranteed to cover statement coverage, 100% statement coverage. And remember in the previous test cases that the first test case cover this path, the second test case cover this path. So I cover these 2 paths, but I cover all the statements. So let's consider this example again. Here it will show again statement coverage. 4 with 6, which statements will be covered? This one what I gave the previous example. Here there is another values we use as a test cases. 6 divided by m divided, it's greater, so it will cover here, and the division result here is not 0, so it will go here. So by this test case, only one test case cover all the statements. You can see here by running all. But for my design in the previous example, in the previous slide, I create 2 test cases, but another professional tester, he select these values 6 and 4. 6 and 4, it will cover all the statements. But for my design in the previous slide, I create 2 test cases. If you remember it, I already erased, right? So depends on the how is the tester is expert to select the best test cases. So in the structure testing, so here only one test case to cover all the statements. If you use 4 and 4, so here you cover the decision here, this one. It's not covering this one part. You can see n is not greater than m, so it will go here. And then it come here, it's equal 0, then it will go here. Then I click. So in decision coverage, I use 4 and 4 to cover this branch or this decision with this decision. The previous test case here will cover this decision, this decision and this decision. This one will not be covered. So in decision coverage, I need 2 test cases. In statement coverage, I need only 1 test case, which is this one. It will cover all, but I don't cover this decision. For path, only I cover 2 paths. Okay, so this one can be control for is object oriented. It's good for complexity, to show the complexity of the code. And then we can use these tools to support measuring the coverage that can be used in the execution to show us what is the percentage of coverage that have been covered during the testing. I finished this part.